2024 A-Level Combined Method is paper 1 part B question number 17 part C. Parts A and B of this same question were discussed in previous videos. Links are top right. Part C of this question has to do with trigonometric equations and inverse trigonometric functions. The question says solve the equation tan inverse of x plus 1 plus tan inverse of x minus 1 equal sin inverse of 2 over root 5. Now to solve this equation, let's rewrite it and identify exactly what each of these terms are. So we have tan inverse of x plus 1 plus tan inverse of x minus 1 equals sin inverse of 2 over root 5. Now looking at this equation, the first part is tan inverse of x plus 1. X plus 1 is a certain value and tan inverse of x plus 1 is a certain angle. Similarly, tan inverse of x minus 1 is the tan inverse of a certain value and that is a certain angle. So here we have two angles, tan inverse of x plus 1 and tan inverse of x minus 1, that are then added together and are equal to another angle, which is the angle sin inverse of 2 over root 5. Now in order to solve this, we are going to let each of these angles have a particular symbol. So we'll say let and we'll say alpha equal the first angle tan inverse of x plus 1. We'll also say let comma beta be tan inverse of x minus 1, and we'll also let this other angle here be the angle theta, let's say, equal sin inverse of 2 over root 5. Now given this, we can see if we take the tangent of both sides here, tangent of alpha must be equal to the tangent of tan inverse of x plus 1, which must be equal to x plus 1. Remember, when you have the tangent of the tan inverse of value, let's say x here, it is equal to x. Now also remember, if you have the tan inverse of tangent of x, this is not necessarily equal to x. It might be equal to, but it's not necessarily equal to. The same of course goes for cosine and sine. If you take sine of sine inverse of an angle, it is equal to the, or rather a value, it is equal to that value. But if you take the sine inverse of the sine of value, it is not necessarily equal to the original angle. Now in this case we can see, since we have tan inverse here, when we take the tangent of tan inverse, we do get the original value, which is x plus 1. Similarly, for beta, if we take tan beta, we will get the tangent of tan inverse of x minus 1, which is equal to x minus 1. Now, we could take the sine of both sides here and write that sin theta is equal to 2 over root 5. But in our case, we can see, since we want the tangent of alpha and tangent of beta in order to do these two substitutions, we probably don't want to use the sine of this angle. Instead, we would like to find the tangent of this angle. So moving on from that, we can see if we do these replacements, then our equation above turns into alpha plus beta equals theta. And from this equation we can see, if we take the tangent of both sides, on the left hand side we get tangent of alpha plus beta, which is of course equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta, which we could substitute with x minus 1 and x plus 1, but then we need to find tangent of theta. Now in order to find tangent of theta, what we're going to do is to consider the sine value of theta, and using that we're going to draw a triangle that we can then use in order to find the tangent value of theta. So for this, let's draw a triangle with one of the angles being equal to theta. So we'll draw a triangle like this, 90-degree angle. We'll say sin theta equal to 2 over root 5, and using that we'll find what the other angles and other values should be. So considering this, we can see if this angle here is theta, then the ratio of the opposite to the hypotenuse must be 2 to root 5. Therefore, if the length here is 2, then the length of the hypotenuse must be equal to the square root of 5. Now considering this setup, if we apply the Pythagorean theorem, we can see root 5 squared is 5, so we have 5 equal this side squared, which is going to be 2 squared, which is 4, plus this side squared, which I'll call a for now, plus a squared. Rearranging this, we can see we get a squared equals 1, and therefore since a must be a positive length, a equals 1. So according to that, our triangle has a hypotenuse of root 5 and the other two side lengths are 2 and 1. The side length opposite to the angle theta is 2 and the side length adjacent is equal to 1. So according to this, we can see if we take the tangent of theta, the value we get is opposite over adjacent, which is going to be equal to 2 over 1, which is going to be therefore equal to 2. So according to this, we get tangent of theta equals 2. So due to that, if we take the above equation, which is this equation, I'll call it equation 1 for now, and we take it, and we take the tangent of both sides, tangent of alpha plus beta is equal to tangent of theta, and therefore, if we take this and expand, on the left hand side, we can expand tangent of alpha plus beta based on the identity we know as tan alpha plus tan beta divided by 1 minus tan alpha tan beta, and similarly on the right hand side we can replace tangent of theta with the value that we know, which is 2. So therefore we get this equation, tan alpha plus tan beta divided by 1 minus tan alpha tan beta is equal to 2. Now what we can do is to take our original equation over here, use the fact that if we use alpha equals tan inverse of x plus 1, then tangent of alpha must be equal to x plus 1, and similarly for beta, tangent of beta must be equal to x minus 1, and we can substitute in these two values for tangent of alpha and tangent of beta. So according to that, tangent of alpha is x plus 1 and tangent of beta is x minus 1. So substituting that in, we can see we get x plus 1 for tangent of alpha plus x minus 1 for tangent of beta divided by 1 minus tangent of alpha, which is x plus 1, times tangent of beta, which is x minus 1, equals 2. Now simplifying this, we can see on top we get x plus 1 plus x minus 1, plus 1 and minus 1 cancel, leaving us with x plus x, which is 2x. So therefore on top here we have 2x divided by, and at the bottom we have 1 minus x plus 1 times x minus 1. Now x plus 1 times x minus 1 is of course the difference of squares, which means that this term is going to be x squared minus 1 squared, which is x squared minus 1. So therefore we have 1 minus x squared minus 1. So according to this, we simplify, we can see the minus and minus cancel, leaving us with 1 minus x squared plus 1, which turns into 2 minus x squared. Therefore the denominator here is going to be equal to 2 minus x squared, which is equal to 2. Now simplifying this down, we can see we can cancel this 2 for this 2, leaving us with x equals, and we take this to the other side, 2 minus x squared. So we get x equals 2 minus x squared, and if you simplify this, we can see we get x squared, and then if we take this to the other side, we can see we get minus x, but if we multiply everything by minus 1, we get plus 6, and then minus 2 equals 0. Now factorizing this thing, we can see if we consider term here, we have x squared and minus 2, which means our two factors are going to be 1 and minus 2, or minus 1 and 2, and according to this we can see we need plus 2 and minus 1. So therefore our factors are going to be x squared plus 2x minus x minus 2 equals 0, which turns into x plus 2 times x minus 1 times x plus 2, which then transforms into x minus 1 times x plus 2 equals 0. Now finally we can see if the product of these two is equal to 0, then either this term is 0 or this term is 0. According to that, either x minus 1 is 0, which means x equals 1, or x plus 2 is 0, which means x equals minus 2. So therefore, from this equation, after substituting tangent of alpha and tangent of beta, simplifying tangent of theta and doing all of that, we get two solutions, x equals 1 or x equals minus 2. Now out of these two, we need to see whether both of them are solutions, one of them is a solution, or none of them are solutions. So considering this, if we now go back to our original equation, which said tan inverse of x plus 1 plus tan inverse of x minus 1 equals sin inverse of 2 over root 5, and consider each of these values, we will see one of them works and one of them doesn't work. So writing this down, we have tan inverse of x plus 1 plus tan inverse of x minus 1 equals sin inverse of 2 over root 5, and I want to bring to your attention that since this value is positive, inside of our triangle, for the angles in between negative pi by 2 and pi by 2 for sin inverse, we are going to get a positive value for the sin inverse of 2 over root 5. According to that, the sin inverse of 2 over root 5 is greater than 0. So now, considering our two values, For x equals 1, we get tan inverse of 1 plus 1, which is tan inverse of 2, which is going to be the first angle, but then we get tan inverse of x minus 1, which is 1 minus 1, which is 0, and tan inverse of 0 is 0. So here we get tan inverse of 2, and here we get 0. And that's equal to the right hand side, which, as we know, the sine inverse of 2 over root 5, as we proved above, is also equal to the tan inverse of 2, as tan of theta is equal to 2. So according to that, on the left hand side we have tan inverse of 2, and on the right hand side we also have tan inverse of 2. So this one works. However, considering the other angle, or other value of x and the other angles we get, the other value of x is x equals negative 2. And considering that, the angles we get here for the first one is going to be the tan inverse of, and here we get negative 2 plus 1, which is negative 1. So it's going to be the tan inverse of negative 1. And then we have plus, and for this one, we get the tan inverse of x minus 1, which will be tan inverse of negative 2 minus 1, which is the tan inverse of negative 3. Now, since this is the tan inverse and we have negative values, both of these angles are negative. This angle is negative, is less than 0, and this angle is also negative, is less than 0. But when we add these two together, we must get this angle, which is of course definitely positive. So according to that, a negative angle plus a negative angle can never be equal to a positive angle, and we can say, due to that, this value of x equals negative 2, is not a solution. So what we have to say here is, considering values of x equals 1 is a solution because it works, but x equals negative 2 is not a solution. And for this, we could give a reason. In fact, I'll give a reason for now, but we don't really have to, but we could give a reason. So my reason is, we get tan inverse of negative 1 plus tan inverse of negative 3, which are both negative. This is less than 0 and this is less than 0, but that's equal to sine inverse of 2 over root 5, which is greater than 0. We can write this is greater than 0, and this is a contradiction, which means that x equals negative 2 is not a solution. However, x equals 1 is a solution, and therefore we can finally say, therefore x equals 1 is the solution, and it is the only solution that we could find. And with that, we are done with this question. So now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you take these equations and you substitute alpha and beta and theta, and for theta, when you consider triangle involved and see that if the sine of theta is equal to 2 over root 5 in this triangle, then the tangent of theta must be equal to 2. When you say this, you get 5 marks. Now after that, when you take the equation that you are given and substitute alpha, beta and theta, and then you take the tangent of both sides, for taking the tangent of both sides like this, you get 5 marks. After that, when you substitute tangent of theta like so, and then expand tangent of alpha plus beta like so, you get another 5 marks for that. And then when you substitute tangent of alpha's value and tangent of beta's value like so, you get another 5 marks. Now after this point, when you go down, simplify everything and get the equation x minus 1 times x plus 2 equals 0, you get 5 marks for that. When you say the two solutions are x equals 1 or x equals negative 2, you get 5 marks. And finally, when you consider two values x equals 1 and x equals negative 2, and you see for our equation x equals 1 works, however x equals negative 2 doesn't work, because x equals negative 2 makes a negative angle equal to a positive angle, which simply cannot work, is a contradiction, it doesn't work, which means that x equals negative 2 is not a solution. And then you finally conclude that x equals 1 is the only solution. You get a final 5 marks for that. And with that, we are done with this question, and we are also done with the pure part of the 2024 A-Level Combined Mathematics paper. So I hope you enjoyed. If you have any feedback, post the comments down below. If you're interested to check out the applied part of the same paper, thank you for watching and goodbye.